Hello, fellow Scratchers. Yes, we are back for another fruity episode of Lemonoid Invasion. I can't tell you how excited I got putting this particular tutorial together because, well, this one is all about special effects and game polish. Yes, finally, by the end of the episode, we will have put together all the action you are seeing right here. All the sounds, all the flashes, pops and lighting. And of course, the awesome camera shake. Oh man, this is going to be fun. Are you ready? So let's get juicing. So, here we are at the end of episode 2. Oh wow, it suddenly feels rather bland, doesn't it? The first thing I notice is how easy it is to break up these large lemons. You'd expect it to take a little more firepower, right? We can address this by giving each lemon its own health level. Click into the lemon sprite and make a new variable named health for this sprite only. Yeah, each lemon has its own health. Now, just before we create a new clone, set the health to 15. I'm intending that we have to shoot a lemon around 15 times before it splits. Find the define enemy hit script. This runs whenever a lemon is hit by a laser. We need to check how much health this lemon has. So check if health is greater than 0. If it is, then we change health by -1, that's -1. This is a typical pattern. If the lemon has health, then we now take some away. If it's hit enough, it will have no health left. But in the meantime, what else do we want the hit lemon to do? We want to show that the lemon was damaged. This is often done in computer games by flashing the impacted object white, just for a moment. We can do the same by setting the sprite's brightness effect to 100. Great, that's all for now, so drop in a stop this script. Otherwise the lemon will split right now, and we don't want that yet. Okay, let's give that a test. Here comes the first lemon. If I shoot it, yes, the brightness effect is working. The lemon turns perfectly white. But yeah, we will have to tell them to go back to normal, as we don't want them to stay this way. We'll sort that out in a moment though. After shooting a lemon 15 times, it finally splits, and then a single shot is all it takes to destroy the smaller lemons. What I realise we are missing though is the sounds of those dramatic impacts to match up to the visuals. Do you still have the all audio sprite in your project from last time? Click in there and we'll look at the sounds. Okay, these 3 explosions are what we are after. Copy all 3 into the lemon sprite. If we have a quick listen, explosion 6 is a small fuzzy boom. Explosion 2 is a softened version of that same sound. It's made a little shorter. And explosion 18 is a big boom. Cool. Click back into the lemon sprite, and we'll start with the big lemon being shot but not destroyed. And we'll want the short impact sound. Start sound, explosion 2. Just when we change health by -1. Okay, we can test that. Yeah, nice. Oh, let's sort out those white lemons. They don't want to stay white forever, right? The simplest way to stop this is to come back to when I start as a clone script and set the lemon's brightness to 0, right at the top of the forever loop. A brightness of 0 resets it to its normal base level. And setting it at the start of the repeat loop ensures each frame begins with no white lemons. That is until they're hit by a laser. Testing again. Oh yes, lemon-tastic. I like those flashes. How about those other explosion sounds then? We have the big explosion and the smaller explosion sounds. Find the define enemy hit script again. To tell the difference between a large and a small lemon, we'll use an if-else block and check for a size being greater than 250. Our first lemon is size 300 after all. So, a big lemon has a size greater than 250, so start the explosion 18 sound. The small lemons can just start sound explosion 6. Oh, and since we know what size of lemon we just destroyed, why not set health to 4 here, so that we need to shoot the next largest lemons 4 times more to get their health down too. That should work well. It's because we don't give the split lemons any extra health that they otherwise only take a single shot to destroy now. Yeah, coming along nicely. But there's still not enough visual feedback from all this firepower. We need particles, explosions, or something. What I'm going to add is a small bright light flash, white explosions if you will, as these can look awesome in space games, and are quite easy to draw in Scratch. Now we could add the explosion costume to the lemon sprite and switch to it when it explodes, but that would cause us trouble. The reason is that the large explosion would then still count as a lemon sprite, and all our lasers would continue to bump into it. That would not be very professional looking, so we'd be better making the explosions in a new sprite. Create a new sprite and name it Boom. Do you like the name? Right, let's get arty. We're going to start by drawing a filled circle with a width and height of around 50 pixels. Now to do this, I zoom in and start at the middle point. Count diagonally left and up by 6 grid squares. Then click and drag with the Shift key held down. Remember that makes a perfect circle. And finish with my mouse 6 diagonal squares down and to the right of the middle. If you check your size, that should be around 50 pixels. Oh nice, spot on. Now with the selection tool, drag and snap the circle to the center of the drawing canvas. Brilliant. I just need to change the fill color to white and its outline to transparent. That already looks quite cool on the stage, but you wait till we add a light haze around it. Hold down the Alt key and drag the previous circle to create a copy. Now snap it back to the center over the first circle, and then holding down the Alt key again, drag the corner outwards to around double its current size. I want a sprite size of around 110 from this. Okay, this is the fun bit. Click into the fill color and switch to the circular gradient pattern. We want to keep the center white, which it already is. So click the right-hand black color swab and we can switch it to transparent. Yeah, now the circle fades off to nothing at the edges. We don't see the effect on the stage until we close the color chooser. Oh yeah, look at that, cool. That's beautiful. We are going to have fun with this. Let's name the costume Flash. That will do for the smaller explosions, but we need another more dramatic one too for the big lemon. Duplicate the Flash costume and name this one God Rays. We are going to draw some big rectangles. So select the rectangle tool and then we must remember to click into the fill color and switch back to a solid white fill. Now zoom right out as far as you can until you see the full canvas and beyond. We need these God rays to be really long. So start drawing at the far left and we finish over on the far right. Height-wise, it's roughly as tall as the original outer circle, perhaps. Now, using the shaping tool, I can pull in one side to make it nice and narrow. Now, these rays want to radiate out from the middle of the ball of light. So drag it so the smaller end is right in the middle here, like this. Next, we will make another light ray by holding Alt and dragging the first one. Rotate it, and then position again with its pointed end at the middle of the light ball. Do this a few more times, making some thinner than others works well. And hey, presto, one rather gorgeous light ball explosion effect, complete with God rays. We now have an awesome sprite, so we just need a way to make them appear where they are needed. If you remember our laser sprite, we were able to create a clone of the laser from the player's script. Could we do the same here? Create an explosion from the lemon, perhaps? That would be nice, but sadly the clone would not be positioned at the lemon, and neither would it know which lemon created it. Now we could store the position of the exploded lemon in a forAllSprite variable. Then the new clone could take that position from that. But that would limit us to one explosion at once, and we may need more than one. That points us to a better solution of using a forAllSprites list. We can then make a record of as many explosions as we want to be generated. Let's do that. Make a new list, naming it Bang. Tick for all sprites. Start by hiding the sprite by clicking the Hide button. and I'm going to add a simple script to allow us to test the explosion scripts as we work. I want to clone a new boom sprite at the mouse position when I press T. So when the T key is pressed, that's a T for test of course, start by adding 1 to the bang list. This says our new clone will use costume 1, at least it will. Then we add the position of the clone. So add mouse X and then add mouse Y. There, we don't need to run the project to test this. Just position the mouse on the stage and press the T key. Aha! See how the bang list now contains the costume and position of the mouse as the first 3 items in the list. I can move the mouse and again press T. And now I have a second set of 3 items added to the list too. A costume number followed by an X and a Y position. Good. This repeats for as many explosion sprites as we need to clone. Now we just need to write the scripts to actually create the explosion clones from this list. We'll begin as normal with a when green flag clicked hat block. Next, keep things tidy by officially hiding the initial sprite. We can also delete all from the bang list just in case it has stuff in it. You never know, and erroneous data can cause unexplained bugs later on. So now, down to business. Add a forever loop. We're going to be looping around waiting for something to be added to the bang list. So if the length of bang is greater than 0, we will do something. Right, we need to consider the first 3 items of the bang list. The first item is the costume, so switch the costume to item 1 of bang. Next up, the X and the Y positions, so set X to item 2 of bang, and set Y position to, can you guess? Yeah, item 3 of bang. I think that makes a lot of sense. Having read in these top 3 rows, we should now delete them from the list. Otherwise, we'd end up cloning even more explosions at the same position. To do this, we just delete item 1 3 times in a row. I know that doesn't sound right at first glance, but once you realise that deleting item 1 causes the rest of the items in the list to shuffle up a row, then you can see that deleting item 1 again makes sense, and we can do this 3 times to remove the top 3 items. Cool. Now create the clone of myself to start off a new boom sprite clone, with the costume and position we have just set. If there are more items in the bang list, then this loop will go around again and create another clone. We can almost test this, but we must make the new clone visible first. When I start as a clone, show. Now I want to test this, but I won't run the project. I'll just click this green flag script with my mouse to start it off. So, with my mouse over the stage, I press T. And yeah, we've cloned a beautiful light bloom. As I repeat this action, you'll note that each successive bloom is getting lighter. Now that's odd. Why is that? Well, this is the same issue we saw before when we have a key press event trigger on a sprite that has clones. All the light bloom clones on the screen are adding explosions to the bang list when I press the T. Not to worry though, as this was just a test key press and it won't be like this in the real game. Our next job is to get the explosions to fade out after being created. Start by pointing it in a random direction between -180 and 180. This will be more useful later on though. Now, we can use await 0 to ensure we see the sprite before we start to animate it. Make a quick fade using a repeat for, and change ghost effect by 25. After this, the sprite will be completely invisible, since 4 25s is 100. So we finish by deleting this clone. I'll test again by carefully clicking the green flag hat script. Tapping the T key now flashes up the light effect, and they do quickly fade away. That's perfect, almost like little popping fireworks. That's going to look great in game. So how about costume 2, the God Rays? We can switch to testing these by updating the when T key press script and setting the first item to a 2 for costume 2. Click the green flag script again, and let's see what the T key does now. Well, That's as expected. The god rays do look good, but we can do better. On a side note, you can see why we pointed in a random direction now, as it makes each god ray appear to look a bit different. Okay, to improve the god rays, we want them to stay on screen a bit longer, and perhaps to have a bit of a rotation effect. Since this is only for the god rays, that is costume 2, add in an if after the initial weight 0, and check whether costume number equals 2. Repeat an extra 4 times now, I think. This time, just turning right by 1 degree. No fade out yet. Then in the second original repeat, also add a turn by 1 to continue the effect. Let's test that again by clicking the green flag script here. Now press T. Oh yeah, look at that. That slow rotation really makes this effect stand out. Nice. Let's get this in game. Delete the testing script as we've done with that. And click into the lemon sprite. Here's the define enemy hit script, and we should be creating our boom sprites right here as we play the sounds. So we need to add 3 rows to the bang list to create a clone, right? We'll start with the big lemon god rays. Set a costume number of 2, and then the position of the lemon to be exploded, that is its X position and Y position. We can duplicate that and put the first stack here in the if, and the other stack within the else. Since the else is for smaller explosions, switch it to create a costume 1 explosion. Before we test this, I spot that we can make an optimization. See that both the if and the else end by adding the same 2 items to the boom list? We can therefore remove these 2 lines from each if-else branch and place just 1 copy below instead. That will do just the same thing in less blocks. Okay, I am excited to give this a go. Let's run the project for real by smashing that green flag. And we are off. Yes, it's working. The initial boom of the first lemon is really cool. And then, as we clean up all the smaller lemons, we get these very satisfying pops. So good. Now, there's just one thing missing that would really just bring the whole thing together. And what's that? Camera shake. We've all seen it, and perhaps it's overused in games? No, we really want it, yeah. So what's the theory behind this? Well, imagine the shock of the blast from the exploding lemon is so great that it actually knocks and shakes the entire screen itself. Funnily enough, this is much easier to do if your game is already a scrolling game, because then we already have an easy way to move the entire screen around. But in a game such as this, we don't have that yet. So let's try and work with what we've got. We'll start by adding an event to trigger this motion. Broadcast a new message. When the large lemon is destroyed, here, and name it Shake. Now we'll start coding this in the player sprite. We need to be able to move everything on the screen by the same amount to simulate a shake. Create a new variable naming it ShakeDX for all sprites. This is the amount each sprite is to move in the X direction. And of course we need a matching ShakeDY too, again for all sprites. Set them both to 0 after the green flag is clicked. So like I said, everything wants to move by this amount each frame of the game. So find where we are moving this player sprite, here in the Move X and Move Y custom block scripts, and add ShakeDX to SpeedX and ShakeDY to SpeedY. Nice. Okay, we need to do the same for every sprite. So click into the laser sprite next. So where do we move this one? Yeah, here. Add in a new change X and change Y. And just change them by ShakeDX and ShakeDY too. That should do it. Next up is the lemon sprite. Okay, yes, this movement scripts are here under the when I start as a clone. We do exactly the same thing again. Change x by shake dx, change y by shake dy. Super! We can give that a test. Click the green flag. Now to see the shake variables in action, we can double-click the shake dy reporter twice to change it to a slider. This only works when not in full screen. And now if I drag the slider around, whoops, everything just races up the screen. Wow, that was quicker than I expected. And of course, if we do the same for shake dx, then everything rushes over to the right. So, where does that leave us? I guess if we were to wiggle the shake dx and shake dy sliders left and right quickly, we could imagine the screen would look to be shaking around, right? And yes indeed, that is exactly what we're going to do. The trick is being able to move it in a way that keeps things centered on the screen, and looks like a nice impactful shake. Click back into the player sprite, and in some free space, pop in a when I receive shake. So, first, we must decide on the initial direction of our shake. I feel the shake should be away from the lemon we shot. That should be roughly in the opposite direction to how our ship is facing if we were just shooting at the lemon. So, using those clever maths operators sine and cos again, we covered that in the last episode, set shake dx to the sine of our sprite's direction, and set dy to the cos of our direction. Now, that will be a shake speed of just 1 pixel and towards the lemon. That's really slow, and in the wrong direction. We should multiply it by a large negative number to fix that. In fact, we'll make a new custom block for just that. Name it shake, and add 2 numeric inputs, dx and dy. That is how much we're going to multiply shake by. Note here, we are not ticking the run without screen refresh block. That's right, don't tick it. You'll see why soon. Set shake dx to itself, that is shake dx, multiplied by the new input dx. And set shake dy to shake dy multiplied by the input dy. Now, the thing about our shake is we want it to take some time to occur, but since we've only updated a variable in here, this won't happen by itself. We therefore add in a wait 0 here to force a screen update before continuing. That gives everything time to shift on the screen. It's also why we didn't tick the run without screen refresh, as that wouldn't allow us to do the wait in here. And now, I'm going to wait 0 again. Why? So that everything on screen will move by the same amount of shake dx and shake dy again. That makes for a much more authentic shake, as it amplifies the back and forward motion over 2 frames beautifully. Great! So we said we wanted to multiply shake dx and dy by a large negative number. Let's do that now, using our new custom shake block, multiplying by -16 in both the x and y directions. 16 pixels is a nice strong shake. That will shake everything on screen by this much, to about here. Now, each time we shake, we want to move in the opposite direction. So, the next shake wants to take us back through to the opposite side of where we just came from. That would require us to move almost twice as far as the last time, and again in a negative direction. To achieve that, we would multiply the original shake by just less than -2. I'm going to pick -1.8 for the x and y. We use just less than 2 so that the shake will slowly get less over time. Okay, so the shake has really begun now, so we can create a repeat loop to continue the action back and forth. Repeat, say, 16 times should do, and use a shake block again. How much? Well, now that the shake is in full motion from side to side, we want to multiply by just less than -1, that is, to ensure the shake keeps decreasing, but flips from left to right. We'll use a random number. Pick random -0.5 to -0.8, and the same for the second input too. Finally, to clean up, add a shake 00 at the end to stop any further movement. This is important as otherwise our whole game may slowly drift out of sight. Right, let's spin it up and give it a final test. Take this, lemon. Oh, this is great. You dare to invade our galaxy? Not on my watch. This shake just looks awesome and blends perfectly with all the other effects we've added too. Boom! I shall single-handedly put a stop to this. Oh man, so obviously, you may have noticed, I can't actually die yet in this game. But I can tell you things are getting rather out of hand very quickly. What I would suggest is we make the lemons begin spawning a lot slower than they are. Click into the lemon sprite, and if you remember, we can set the delay between lemons here in the green flag script. Set it to something like 5 seconds. And the original pause before the first lemon appears, that can now be 2 seconds. And this is it. We have caught up with the game as I originally designed it for you in the first episode. We have created Lemonoids. Okay, so it's by no means a finished game, but I wanted it to be more of a catalyst to give you ideas of games you could make for yourselves. There's so much left you could add, not least a simple way for your player to end the game, either by winning, or more likely fighting until you are overcome by lemons. Now, I may well be tempted to make a follow-up video to answer outstanding questions posed by my fellow Scratchers. So go to town, make something amazing with what we've covered in these 3 episodes, and then bring your questions and ideas back here in the comments, and I'll try to pull it all together in a fresh new video for you all. And that brings us to the end of this video. If you've enjoyed it, then please smash the like button, and do please click to subscribe to the channel if you can. That helps me a lot. And I really do need your support. Making these videos takes a lot of time and effort, and that's why I also opened up the channel membership. Supporting me financially will allow me to continue to create more great content for you, and also you get some cool extra perks. Yep, you can get early access to videos before everyone else, priority access to me in the comments, and well, the projects themselves if you wish. If you're an educator or parent, then it's a super deal, so please check that out. Right, until next time though, have a great week ahead, and don't let the lemons bite. Scratch on, guys!